Hello everyone, in this video we're going to discuss molar volume. So these are the theories of Avogadro's law, which is 1 mole of N2 equals 28 grams of nitrogen gas equals to 6.02 times 10 to the power of 23 molecules of nitrogen gas. And 1 mole of carbon dioxide is equals to 44.01 grams of carbon dioxide is equals to 6.02 times 10 to the power of 23 molecules of carbon dioxide. So 1 mole of any gas is equals to molecular mass is equals to 22.4 liters at STP. So any compound is equals to 6.02 times 10 to the power of 23 molecules of a compound. Okay? And 1 mole of any gas is equals to molar mass, a molecular mass, or 22.4 liters of gas at STP. So let's begin in number 1 problem. So a sample of gas has a mass of 1.248 grams and occupies 300 cubic centimeter at STP. What is the molecular mass of this gas? So we need to find the molecular mass of the gas, which is right in number 1. So we have a volume here. So we need to ratio this and this. So 1.248 grams. So you write here 1.248 grams is equals to 300 cubic centimeter. So equals to 300 cubic centimeter. And 22.4 liters at STP is equals to 1 mole of gas. Okay? So the question is, what is the molecular mass of this gas? So we need to solve that in solution. So molar mass of gas and molecular mass of gas is equals to, here we need to use this ratio. So 1.248 grams of gas over 300 cubic centimeter times 22.4, which is the STP. So times 22.4 liters at STP over the 1 mole of gas. And liters and cubic centimeter cannot be converted, so you need to convert liters to cubic centimeter. So in 1 liter we have 1000 ml times 1 ml is equals to 1 cubic centimeter. Okay? So you need to cancel the liters here. How about the ml? The milliliters, and the cubic centimeter will be cancelled. So the left is grams per mole. So that's the unit of molecular mass. So molecular mass of gas is equals to, calculate all, 1.248 divided by 300 times 22.4 over divided by 1 times 1000 divided by 1 times 1 over 1 is equals to 93 93.184 93.184 grams per mole. So you need to write here grams per mole of gas. So this is your final answer. Okay, did you understand it? And how about problem number 2? So in problem number 2, how many grams of carbon dioxide will occupy a volume of 500 cubic centimeter at STP? So let's solve that again. How many grams of carbon dioxide? So let's begin. Number 2, you write here 1 mole of carbon dioxide, we need to write a ratio first, is equals to 22.4 liters of carbon dioxide at STP, and 1 mole of carbon dioxide is equals to 44.01 grams of carbon dioxide. Okay, that is this unit will be the molecular mass. So molecular mass of carbon dioxide is equals to 12.01 plus 16 times 2 is equals to 44.01 grams per mole of carbon dioxide. These are the same. Okay, that's are the same. And we need to find the grams of carbon dioxide here. The question is a question. So let's begin again. We have a volume here at 500 cubic centimeter. So we write here the volume, which is 500 cubic centimeter. So let's begin. We need to solve the mass of carbon dioxide. So mass of carbon dioxide is equals the molecular mass, which is 44.01 grams of carbon dioxide over 1 mole of carbon dioxide. You need to use the molecular mass or the ratio. Okay, and then times 22.4 liter divided by 22.4 liters of carbon dioxide and 1 mole of carbon dioxide times the 1 liter, we have a 1000 ml, and then 1 ml, we have a 1 cubic centimeter, times, we have times here, times 500 cubic centimeter. So you need to cancel by mole here. The liters cancel, and the ml will cancel, and the cubic centimeter cancel. So calculate first. So 44.01 divided by 22.4 liters times divided by 1000 ml times 1 over 1 times 500 cubic centimeter is equals to how much? So the mass of carbon dioxide is equals to 0.9823 grams of carbon dioxide. Okay, that's it. That's the final answer. And how about problem number 3? So a reaction produced of 200 cubic centimeter of oxygen, which is collected over water and measured at 22 degrees Celsius and 9.90 times 10 to the power 4 Pascal. how many grams of the gas are produced? Assume the water vapor pressure of 2.6 kilopascal at 22 degrees Celsius. So this problem was we call a molar volume again, and we are using Dalton's law of partial pressure. So in number 3, let's begin. So we have a volume here. So the volume of a gas is equals to 200 cubic centimeter. 200 cubic centimeter. And the water vapor, which is water vapor here, is 2.6 kilopascal. So we have a pressure water vapor is equals to 2.6 kilopascal here. 2.6 kilopascal. And we have PATM, the atmospheric pressure, is equals to 9.90 times 10 to the power 4 pascal. So right here, 9.90 times 10 to the power 4 pascal. So we need to convert into kilopascal. So in 1000 pascal, we have a 1 kilopascal. So here, 9.90 times 10 to the power 4 divided 1000 is equals to 99 kilopascal. Okay. And then, what's the temperature again? The temperature one is STP. So it's 273 Kelvin. And the pressure one again, a standard pressure at STP is called 101.325 kilopascal. And then the temperature 2 is equals to 22 degrees Celsius here. 22 degrees Celsius. 22 degrees Celsius plus 273 Kelvin is equals to 295 Kelvin. Okay? So we need to solve the pressure 2 again. So pressure 2 is equals to P gas. Here is a solution here. P gas is equals to PATM minus P water vapor. So P2 is equals to how much PATM again? The PATM is equals to 99 kilopascal. So 99 kilopascal minus the water vapor pressure is 2.6 kilopascal here. 2.6 kilopascal. So P2 is equals to 99 minus 2.6, which is 96.4 kilopascal. So we have a pressure 2 now. So we need to solve the buoyant and oxygen gas. So volume of a gas times pressure 2 over pressure 1 times temperature 1 over temperature 2. So volume of a gas. So volume of a gas is 200 cubic centimeter. So 200 cubic centimeter. And the pressure 2 again. Pressure 2 is 96.4 kilopascal. So 96.4 kilopascal. And the pressure 1, which is the standard pressure, 101.325. So 101.325 kilopascal times the temperature 1, which is 273 Kelvin here. 273 Kelvin. And the temperature 2, which is 295 Kelvin here. 295 Kelvin. Okay. And then the volume 2. So we need to cancel out kilopascal and Kelvin too. So the left is cubic centimeter. So 200 times 96.4 divided by 101.325 times 273 divided 295 Kelvin. So equals 176 cubic centimeter. So we have a volume now, so we need to solve the mass of oxygen gas. So we have a volume. So we solve the mass again. So the mass of oxygen gas is equals to, we have a volume 2 here. So the volume of oxygen gas times the ratio 1 mole of oxygen gas over 22.4 liters times the molecular weight or the molecular mass of oxygen gas. Okay, we have molar mass of oxygen gas here, which is 2 times 16 is equals to 32 grams per mole of oxygen gas. So let's begin again. In mass of oxygen gas, so how much the volume again? The volume is 176 cubic centimeter. So 176 cubic centimeter of oxygen gas times 1 mole of oxygen gas over 22.4 liters of oxygen gas times the molar mass, which is 1 mole of oxygen gas equals to 32 grams of oxygen gas. Then we need to convert liters into cubic centimeter. So in 1 liter is equals to 1000 ml, and then you need to change times, and 1 ml we have 1 cubic centimeter. So cancel out the cubic centimeter here, and then the ml cancel too, and the moles will cancel, and the liters will cancel, and the left is grams of oxygen gas. So mass of oxygen gas is equals to 176 divided by 22.4 times 32 divide 1 divided by 1000 times 1 over 1. So equals 0.251 grams. 0.251 grams of oxygen gas. So that is the final answer. So I hope it will help you, and please like and subscribe